All right, so we are going to start today with our notes. Make sure you have opened your document that is in Canvas attached to today's assignment. We're going to go ahead and get started with our warm up. Our warm up says, which would leave a salty layer on your skin if you swam in it? Which one would leave a salty layer? Answer in the chat, please. See, I have about 3 people that have responded. I'm waiting for everyone else. All right. So, what I'm seeing in the chat, I'm seeing a lot of C's, which is Baffin Bay. You would be correct. We know that it can't be the lake or the lakes or the rivers for what reason? What kind of water is in a lake or a river? Can you answer in the chat? Good job. It is fresh water. So there's no way that you should have a salty layer on your skin if it is a freshwater source. Alrighty. So we'll go ahead and get started. We've covered about 3/4 of the information that is going to be on your test next week. So today we are going to do the last piece, which deals with water quality, human health, and stewardship. So in the chat box, go ahead and tell me which ones do you think are healthy or unhealthy. You can just type the numbers and that'll be perfectly fine. Which ones do you think are healthy versus unhealthy? All right, so I'm seeing um 5 is unhealthy. 3 and 6 are unhealthy. 1, 2, 5, and 6 are healthy. 2 is healthy. 1 and 2 are healthy. 2 is unhealthy. All right. So, by the time we get finished with our lesson, we're going to revisit these pictures a few times, and we're going to talk about what may be or maybe not be healthy in our different pictures. All right, so first things first, you should have your notes pulled up and you can just type these answers directly on it, so you can be done with that once we are finished with our lesson today. So when it comes to the health of water systems, there are majorly like 3 things that they look at to determine if a water system is healthy. They look at the physical, the chemical, and the biological factors of a water sample. So the physical ones are going to be the temperature, how hot or cold it is, the turbidity, which is a new word for us today. It deals with how cloudy the water is, and the water movement. Is it moving around or is it stagnant and kind of standing still? Is what it's looking for. With the chemical things, we're looking for dissolved oxygen or carbon dioxide for that matter. We're also looking at the pH of the water, dealing with is it acidic or is it basic or is it kind of in the middle and neither one. We're also looking at the nitrates is and the phosphorus level really. the different chemicals and elements and stuff that may be introduced also to the water. We're looking at the amount of them that are in there. When it comes to biological features, we've talked about anything when you see bio deals with life. So for this one, we're looking at the living things that are in the water. We're looking at the fish, we're looking at the plant life, we're looking at the algae content, as well as the different insects that might be involved with that water. So when it comes to water, we know that there's about 3% of all of the water on the earth that we're able to use is fresh water. And within that 3%, only 1% we have access to that we can actually use, because the other 2% are kind of stuck in ice caps and glaciers. But there's only about 1% that we're able to truly use to meet our needs. So with our water sources, it's kind of classified into two areas. Is it potable, which means it's healthy enough for us to drink, or is it safe, meaning not quite good enough for us to drink, but it's okay for us to take a bath in or to clean with it or something like that, but it just may not be good enough for you to drink out of. So if we go back to looking at our pictures we looked at earlier, if I was to take a bath or wash my clothes in any of these waters, I would feel like this water and this water are still going to leave either me or my clothes dirty. One of the two. I probably wouldn't necessarily know if water was acidic if I didn't taste it. However, if I took a bath in it too long, I might notice that it has some reactions with my skin. With this option, with these two, I mean, I would definitely use them to wash with, but I can't say I would actually drink any of them, because this is either ocean water or it could be a pool. And I know ocean water, well, it wouldn't be ocean if it's a freshwater source, but so it might be like the bottom of a lake or a pool, or something like that. But I would know that you don't drink pool water because it's got chlorine and it's, not good for you. This one, it looks fairly clear. It's nice and blue and pretty, and it's moving and all the rest of that. However, I don't know if there's microorganisms in it. I don't know if it's polluted or anything like that. So if I'm going to drink any of them, it's probably going to be this water that comes out of my tap. I would be okay if I had to take a bath or wash my clothes in this, I'd be okay with that, or these two. But these, I definitely would kind of steer away from doing that. All right. So when it comes to other things that we look at, temperature of a body of water is a good indication of the health of it. Also, the type of organisms that live in the area. There are certain organisms that prefer certain temperature ranges, and they kind of stay in that area. So if you look at a lot of fish and you look at their migration patterns, you'll notice that they kind of stay in in areas that have similar climate. So you're not going to see like salmon near the equator, because salmon prefer cooler water. You're not going to see a lot of tropical angelfish up in the Arctic Circle, because they prefer water that's a little warmer. So they do definitely kind of have a preference. But just like we were talking about with our ocean water last week, we talked about how different gases, they react different, and they are different temperatures of water are able to hold different amounts of gases. So our oxygen is going to dissolve a lot less in water that is either moving really, really fast or that is super warm. It's going to dissolve less, and it's going to cause issue with our fish and our other aquatic life. It also can dissolve a lot more sediment as the water temperature is warmer. That can block out the sun and make it difficult for photosynthesis to happen. And we talked about last week how the ocean and our freshwater sources get oxygen in them by either the waves that are created, or it comes from the plants giving off the oxygen because they go through photosynthesis. Now, our new word that we had today, it is turbidity. It deals with how clear or how cloudy a body of water is. So typically, the cloudiness comes from sediment that's dissolved in the water. It may not be fully dissolved and mixed, because if you've ever gone to a beach and collected water, if you're at the beach, especially if you're on like the Atlantic side, a lot of times the water looks kind of dark green, or it may be kind of brown, just depending depending on where you go. But if you collect some of that water and just let it sit, then it eventually becomes clear, and all of that sediment kind of falls to the bottom of it. And you'll look at the sand, you'll see shells and all kinds of stuff that's not necessarily dissolved in the water, but is mixed very well. So if you just let it sit there, then eventually it'll end up looking like regular water. Um, the high turbidity, which is this one, is going to mean that it's non-potable. It can also increase your temperatures, allowing that oxygen to decrease and kind of impairing some aquatic organisms from living and thriving, and we don't want that. So when it comes to water that we're going to drink, we want the kind that has low turbidity, that you can see through, that's pretty much crystal clear, and that's what we want. So if we're looking at our pictures again, this water source would have a high turbidity because of the dissolved material that's in it. It looks really brown. It looks kind of gross. Versus this one being rather low because it's clear. This one is clear. It's rather low. This one, for the most part, is clear. This one is a little cloudy, but it's due to the bubbles and the movement of the water. But if you collected a sample of it, once it's settled, it probably would be kind of clear too. This one kind of has a medium to high turbidity. It does have a bunch of algae that's kind of on top of it, but I can't totally tell if it's also the water that's green or if it's just the way this picture is and the light is bouncing off the algae. So depending on what color the water actually is, that would tell you about its turbidity. All right, so we're going to watch this video. If fish live underwater, how do they breathe? That's the answer that you are going to be able to answer in the chat when this video is over.
How do fish breathe underwater?
With the help of oxygen cylinders and masks.
Nah. Fish breathe underwater using the oxygen that is dissolved in water.
So, do they use a mini vacuum cleaner to absorb oxygen from water?
No. To absorb oxygen from water, fish use special organs called gills. Gills are full of blood vessels. Also, the walls of the gills and blood vessels are very thin. Now, during breathing, fish take in water through their mouth and forcefully push it through their gills. When the water moves through the gills, the dissolved oxygen from the water passes through the thin walls of gills and blood vessels and enters the blood. Apart from this, the waste carbon dioxide present in the blood passes into the water, thus helping fish to breathe underwater. Eventually, the carbon dioxide-rich water is given out from gills.
So in the chat, go ahead and tell me, how do fish breathe underwater? Is it with the oxygen tank? Is that what they need? That'd be interesting, seeing a bunch of fish swimming around with oxygen tank. They use their gills to breathe the oxygen that's dissolved in the water. Okay. Can you drown a fish? It depends, because technically drowning is suffocation by lack of oxygen, usually being underwater. Because we can't breathe in water. I mean, we can't filter out the oxygen from the water like fish can. So if the fish was outside of the water, then pretty much it would still suffocate because it can't process the oxygen that's in the air because it's not in the water. So I guess technically you could suffocate a fish. I don't know about drowning a fish because they live in water. I guess if they were in an area that maybe is out of their normal pressurized area, then maybe. But I don't think you can technically drown a fish. Technically, I don't think you can. I don't know. I could be wrong. Be an interesting thing to look into, though. I'm not exactly sure, but that's just my thought process. Alrighty. So,
how do fish breathe underwater?
We already did that.
With the help.
All right, so next we have our dissolved oxygen. And with our dissolved oxygen, we have two different ways that this oxygen is going to get into our water. One is from air itself being trapped by waves and moving currents. We talked about that yesterday. Well, not yesterday, we talked about it last week. But then we also have plants that are under the water that release oxygen during photosynthesis. So we know that the sun is one of those things that you have to have in order to make this happen. So this is not going to happen in, especially in the ocean, in those deep ocean zones. So it happens in the intertidal area. Somewhat at the top of the open ocean, as long as the sunlight can get down there, but not near the bottoms of the open ocean and going into the deep ocean. It's not going to happen. So this dissolved oxygen is going to definitely help the amount feeding the zooplankton and other fish, and is going to allow them to thrive. The zooplankton is important because they are an important part of the aquatic food chain. So without them, a lot of fish wouldn't be able to live and thrive. Next, we have pH. Our pH deals with how acidic or how basic a water is, or how an object is. pH is measured on a scale from 0 to 14. 0 to 6 is acidic, 7 is neutral, and 8 to 14 is considered basic or alkaline. The pH of water is known as kind of a synergistic effect, which kind of means that whatever the minerals or the elements that you put in them, it can make either more or less of an impact based on the actual pH of the water that you put it in. So certain metals can become more acidic when you put them in water, and some of them can become basic to the point that they are poisonous. All right, so we're going to watch a video. Well, no, let me ask you this. With these objects, would you consider them to be acidic or basic? Orange juice, soap, and water. Do you think they are acids or bases? So we think all of them are acids. Okay. The soap and orange juice are acids. The water is a base. Orange juice is an acid. The soap and water are bases. Alrighty. Let's watch our video, and we're going to revisit that question once it is done.
Welcome to Moo Moo Math and Science and the pH scale. What is pH? Let's start with what it stands for. pH stands for the potential of hydrogen, and it's a measure of the concentration of hydrogen ions in a water-based substance. pH is organized into a scale of acids and bases with neutral right in the middle. The range goes from 0 to 14, with 7 being neutral. pHs of less than 7 indicate an acid, where a pH greater than 7 is a base. But why 7? Because 7 is neutral. One of the first obstacles I had to overcome was remembering which number is neutral, which numbers are acids, and which are bases. So I use lucky 7, or 7 is heaven on the pH scale, to remember that 7 is neutral. And then I know that any number below is an acid, anything above is a base. I also remember by thinking when you base jump, you jump from a high place, so a base must be a high number. Again, remember, lucky 7 or 7 heaven is always neutral. Next, let's go through some items that are acidic or basic. Milk is slightly acidic, along with apple juice, lemon juice, and then stomach acid. Some acids can taste very sour. Some examples of bases include eggs, baking soda, ammonia, and bleach. And a base may taste bitter, and it could also be slippery. Next, the pH scale has colors that go along with acids and bases. Acids are yellow, then change to orange, then to red. And bases are green, then to blue, and almost purple. Again, remember B for base and blue. So what creates an acid or a base? Technically, pH is calculated as the negative log of a solution's hydrogen ion concentration. But in very simple terms, acids gain hydrogen ions and create hydronium, and bases are created by losing hydrogen ions and creating hydroxide. In very simple terms, acids gain hydrogen and bases lose hydrogen. Each number represents a tenfold change in the acidity or basicness of the water. Water with a pH of 5 is 10 times more acidic than water having a pH of 6. If you'd like to know more about pH, this playlist will help. And as always, thanks for watching, and Moo Moo Math uploads a new math and science video every day. Please subscribe and share. Welcome to Moo Moo Math and Science and the pH scale. What is pH?
So back to my original question, see if our answers changed. Which ones are these? Are they acids or bases? Tell me in the chat. You have 3 different options, and I'm just seeing people type base, and that's it. Good job, Marcus. You are exactly correct. Good job, Zaria. You are correct too. Excuse me. All right, so the orange juice would be considered an acid, the soap would be a base, and water should be neutral. All right. So next we have nitrates and phosphates. And with our nitrates and phosphates, they are essential nutrients for healthy plant growth. So if you ever go and start like a garden or anything like that, a lot of times the plant food that you have or the fertilizer that you use will have both nitrogen and phosphorus in it. But just like a lot of things, too much of a good thing is not always a great thing. So if you have too many nitrates or phosphates in your drinking water, it can make it unhealthy. So a lot of sources for nitrates are going to come from runoff that comes from a lot of fertilizers. If you have farmers that are using fertilizer to fertilize their crops when it rains, a lot of those nutrients end up getting transferred right along with that rain. So that can become an issue. Septic tank leaks and sewage leaks can also be an issue as well for having our excessive nitrates. With our phosphorus, you have human and animal waste, as well as laundry, detergents and cleaners, and any kind of cleaners that are used to help clean industrial waste. A lot of times what happens is just like that fertilizer that helps your vegetables and your plants grow, they also help a lot of the algae grow. So if you remember that first picture we looked at, it kind of looked like a swamp. It was a bunch of algae blooms that were sitting on top of it. Well, that can cause an issue because it blocks some of the sunlight from coming in and creates issues and doesn't allow photosynthesis to happen and do what it needs to be doing. All right. So next we have salinity. We've kind of already talked about this, but this is the measure of salt that is in a water. It can be an indicator of water not necessarily being healthy. We know that salinity, a whole bunch of salt should not be in freshwater systems. They'll be found in salt waters like lakes and not lakes, like bays and seas and gulfs and oceans, but they should not be in lakes or rivers or streams or anything like that. A lot of times salinity can enter water systems through weathering of our rocks or wind or rain or any of that sort of thing, but it can be an issue as well. When you have high concentrations of salinity, it can cause the vegetation to become unhealthy. It can die. It can also make some of the fish or aquatic animals die as well, because their bodies aren't used to salt water and can't always process them the same way. It can decrease in biodiversity just because some of those different species may no longer be living. And lastly, we have bio indicators. Biological indicators, also known as bioindicators, are usually macroinvertebrates that give an indication of how healthy your water system is. They are very, very sensitive to change, as well as pollution. So if you look at these microorganisms or microinvertebrates, they'll tell you how healthy the water system is. So if you go and start looking at a pond or a lake or something like that, and you start seeing a bunch of dead fish that are floating around in it, chances are there's something wrong with that water. It could be that it's polluted. It could be that there's like an imbalance in it. I don't know if you guys have ever had fish, or you know people that have had fish or lakes or ponds. Well, sometimes if they get the additives, or they clean it wrong, or they put too much stuff in it or not enough stuff in it, it can cause the fish to just die because they don't have the ability to live in that particular environment. So looking at the living factors that are in there, the plant life, the animal life, the different insects, will tell you if it's healthy or not. They should have a diverse amount of both fish and plants. It shouldn't all just be the one kind, because all of the other ones died off. So it should be a very diverse system and area. Poor water quality is going to be kind of indicated by how few of the bioindicators you had that are actually living and thriving. And that's it for our notes today. So what we are going to do, you should already have this document open, and we should already have all of our notes and stuff done. We're going to go down to this part 2, where we're going to actually practice our water quality vocabulary using quizzes. So if you click the Join My Quizzes link right here, or you can go there and put the numbers in. I know some people use the app on their phone, or they prefer to just put the numbers in, because sometimes the link doesn't always work, but it should. You're going to play and complete the quizzes. You're going to insert a screenshot right here. Once you're finished, your screenshot should have an 85% or higher. It should not be anything less than 85%. If you try it the first time and you don't get 85%, play it again. But your screenshot should have a percentage of more than 85%. If you feel like you need some extra practice, I have linked a Quizlet deck there that kind of has the same words, but it also kind of has words that we are going to cover for the whole water quality portion of our concepts and stuff for this week. So if you want to get a head start on some of the new vocab, or practice some of the other vocab that we covered today, you can click this link right here, and it will take you to the Quizlet deck so you can practice. Does anybody have questions? If you are at home and you're watching this video and you have questions, please send me a message to my Canvas inbox, and I will answer it as soon as I can.